Today we're going to look at function tables. Now this is something that might sound new to you, but it's probably something you've already seen. A function table in elementary school would have been something that you probably called either a T-chart or most likely an input-output chart. So just to look at an example of that, in elementary school you might have seen something that looked like this. You had your input on the left, your output on the right, and you maybe had a rule at the top, and your rule said something like plus 9. So if your input was 4, 4 plus our rule, plus 9, is 13. 5 plus 9 was 14. 0 plus 9 is 9. 10 plus 9 is 19. So that's something similar to what you might have seen in elementary school. Remember, whatever the input is, whatever that number is, and those can be numbers you choose or numbers that are given to you, then you do whatever the rule says to it. In middle school, or as you move further along in math, this is going to kind of transform into something that we call a function table. It's really the same thing, just written differently. Generally, your input is going to be called X, and your output is going to be Y. And your rule, instead of being written, the biggest difference, your rule, instead of being written as something separate and completely not part of the input or the output, it's going to be part of your output because it's going to tell you what you have to do to get the Y or the output. So Y, our output, equals whatever X is plus 9. So we've taken that rule and it's written over here, and we do write this in equation form. So if X is 4, then Y equals 4 plus 9, therefore Y equals 13. If X is 5, then Y equals 5 plus 9, which is 14. If X is 0, then Y equals 0 plus 9, which is 9. If X is 10, then Y equals 10 plus 9, which is 19. So really this is just transitioning to something that you already know, just looking a little bit different. So if we look at a couple of these, if we have M as our input, or M as our first number that we're given, and we want to find H, and we know that H comes from doing M plus 4, then we can do 0 plus 4, which is 4. Then if M is 7, we're going to do 7 plus 4, which is 11. And if M is 5, we're going to do 5 plus 4, which is 9. So when you look at this, notice that if we took our rule or our output and we wrote it on top of what we would have over here on the right, we would be doing M plus 4 equals H. So when you look at this plus 4 right here, that's what we would have in elementary school thought of as the rule. Then we have our M's, which in this case are our inputs, and our H's, which are our outputs. Looking at another example of this, we have R, and then we know that K equals 6R plus 1. So 6R plus 1 really means 6 times some number plus 1. So that's what we're going to do for each of our R values. So for the first one, our R value is 0. 6 times 0 is 0, plus 1 is 1. 6 times 7 is 42, plus 1 is 43. 6 times 5 is 30, plus 1 is 31. And by the way, make sure that you're careful to follow order of operations when you solve equations, just like we've always done as far as having to follow order of operations. That's part of our just rules of how we work with math. Now, in addition to being able to fill out a function table based on being given the equation, you also should be able to look at a filled out function table and figure out the equation that was used to generate that function table. So when we look at this one, we use what we know about patterns and number relationships to do that. When we look at this one, probably pretty quickly you see that each of our H values, 0, 2, 5, and 9, were multiplied by 5 to give us our P values of 0, 10, 25, and 45. So our equation we use in this case is P equals H times 5, or P equals 5H. And typically in algebra you're going to write it with the coefficient and the variable. That's just generally how you write your multiplication once you move into algebra. Alright, so take a look at this next one. Some things to think about. Our numbers are getting bigger. Our outputs or our R values in this case are getting bigger than what the N value was. So we should be thinking, okay, there's got to be either some multiplication or addition because that would make sense. We think about those making numbers get bigger. So if you look at this first pair, you might be thinking, oh, 3 times 2. So maybe times 2 is what I need to do. But when I get down here and I try 4 times 2, I don't get 7. So that's not going to be it. So then start thinking addition. And I can do 3 plus 3 to get 6. 4 plus 3 is 7. 8 plus 3 is 11. So I've got my rule here. Every time I'm going to take the N value and add 3 to it. So R equals N plus 3. Let's take a look at another one. So we look at this one, and we see that our G values are bigger than their B values. So that tells us there's probably multiplication and or addition in this one. Now, looking at this one, we might look for addition first and say, okay, we know that 2 plus 5 equals 7. So could this be that G equals B plus 5? But when we look at our others, 5 plus 5 doesn't equal 16, and 10 plus 5 doesn't equal 31. So that's not it. So then we might start thinking, must be a multiplication. Well, if we do that, we're going to do 2 times 3 1/2. And we could have done 7 divided by 2 to figure out that it was a times 3 1/2. That would have helped us. But then when we start looking, 5 times 3 1/2 doesn't equal 16. And 10 times 3 1/2 doesn't equal 31. Well, so now we've tried all the things that would be the easiest, just a single step equation. So we got to think of something else. And we know the numbers are getting bigger, so I would definitely still think multiplication. And if we think about it, okay, 2 times something, I want to get somewhere around 7. Well, that's 2 times 3 or 2 times 4. 5, I want to get close to 16. Well, that's 5 times 3 is pretty close to that. 10 times 3 is pretty close to 31. So let's start thinking about that. So if we do 2 times 3, that's 6. If we add 1 to it, we get 7. We might be onto something. 5 times 3 is 15, plus 1 is 16. 10 times 3 plus 1 is 31. Now, what would have been really helpful to us here is if we had been given that B is 0 and we had known then that G is 1. If we had known that, then we would have said, plus 1 definitely has to be part of our equation. And the reason it does is because can you multiply B times anything, or B times 0 rather, and get anything except 0? No. So there had to have been a plus 1 here at some point, because multiplying or dividing B by anything is going to give you, or multiplying or dividing 0 rather by anything is going to give you 0. So there has to be a plus 1. Once you narrowed that down, it would have helped you also to see that it was 3 times B, or 3B plus 1. Okay, so let's look then at what we can do with these equations and with these function tables. So what we do with these is we're actually going to graph them. So when you look at this, y equals x minus 1. The first thing you're going to want to do is make a function table of that. Now, I gave you values of x as being 0, 1, 2, and 3. You could choose any values. I just chose those because they're easy to work with. So 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. And 3 minus 1 is 2. Now, here's where the magic happens. When we can look at this and we think back about what we know about x and y, we think about those with a coordinate plane. Well, we can make these ordered pairs. And our ordered pairs are going to be 0, negative 1, which I'm getting from those two values, the x and the y. 1, 0, 2, 1, and 3, 2. Now I can take that, and you guessed it, I am going to graph that. So if I go to graph that, 0, negative 1 is here. 1, 0 is here. 2, 1 is here. And 3, 2 is here. And I could draw a line that connects all of those points. And what's really neat about that is, not only is it going to connect all of those points, but it's also going to, if I look at any point on that line, that ordered pair right here is 5, 4. Notice that ordered pair would fit our function table. I could pick any ordered pair on that line. That ordered pair right there is 8, 7. And 8, 7 would work for that equation because 8 minus 1 is in fact 7. 5 minus 4 is, or 5 minus 1 rather, is 4. So any ordered pair that falls on that line actually fits that equation. I could look at a couple more. If I have this one, take a moment and see if you can fill out the function table. Okay, so if you've done that correctly, you should have ended up with ordered pairs of 0, 3, 1, 5, 2, 7, and 3, 9. And when I graph those, it's going to look like this. Now again, I want you to notice, I could take any point on that line. For example, even if I continued that line here, for example, negative 1. So if x is negative 1, 2 times negative 1, meaning negative 1 twice, is negative 2. And then negative 2 plus positive 3 is positive 1. So notice negative 1, positive 1 is an ordered pair that would fall on that line. And I could come up with any ordered pair I wanted to on that line if I just continued the line. Here's another example, 2x minus 4. See if you can fill out a function table using 0, 5, 2, and 1 as your x values, and then see what your graph is going to look like. Okay, here's what you should have. Again, this one is going to make a straight line. I could look at any value, x value that I wanted here, and say if x, for example, is 4. If x is 4, then I could come up to be on the line. If x is 4, then y must also be 4. I could say if x is 7, here's where 7 is. If x is 7, am I on that line right now? No, I have to go up to get to it. So if x is 7, y has to be 10. Let's see if that works. So 4, 4. 2 times 4 is 8, and 8 minus 4 is 4. Let's try 7, 10. 2 times 7 is 14, and 14 minus 4 is 10. That ordered pair also works. So again, any number, or any point rather, on that line is going to give me an ordered pair that fits that equation of y equals 2x minus 4. One more. If x is 3, 3 times 2 is 6. 6 minus 4 is 2. Notice that that point right there is at 3, 2. One more. This is our last one we're going to look at. X squared plus 1. Try filling that one out and see what it looks like. All right, if you made your chart and your graph correctly, then this is what they should look like. Now notice this one looks very different than the others that we've done. It's not a straight line. All the others that we did were. Think about for a moment if you could come up with a reason why this one might look different. If you look back through your example, see what you can come up with. Give it a moment and think about it. All right, if you came up with the fact that we have an exponent there and that's the reason why we don't get a straight line, you're absolutely correct. Great job. Okay, so the next thing I want to look at is how can we find ordered pairs that fall on a line? And we've kind of already talked about this. If, for example, I give you the order of these 4 ordered pairs and I ask you which of these ordered pairs follows the rule y equals 3x minus 4, you might want to think about this in terms of a function table. So here's x, and we know that y has to be 3x minus 4. So let's look at our ordered pairs. Our x values are 2, 8, 5, and 1. Okay, 3 times 2 is 6, minus 4 is 2. So 2, 2 would be an ordered pair on that line. So that means 2, 10 is out. 3 times 8 minus 4. 3 times 8 is 24, minus 4 is 20. So it's not 8, 4. 8, 4 is out. It has to be 8, 20. If x is 5, 3 times 5 is 15, minus 4 is 11. Aha! It looks like that one is probably going to work. Let's look at our last one just to make sure that there's not a trick question and there's not two answers to this. So our last one has 3 times 1 minus 4. 3 times 1 is 3, and 3 minus 4 is negative 1. So 1, 1 is not going to work. So the only one of these rules where the only one of these ordered pairs rather where the rule works is C, 5, 11. So take a look at these and figure out which rule each of these ordered pairs follows. I've given you 8 ordered pairs. Figure out which of the two rules they follow, or perhaps they follow neither. Try it, pause while you do, and then check your work to see if you're correct. All right, there are your correct answers. Let's try one more. And again, notice the way I know they're correct is if I made a function table for this, for example, for this one, y equals 3x plus 4. Both of those ordered pairs would work. 0. 3 times 0 is 0 plus 4 is 4. If x is 1, 3 times 1 is 3 plus 4 is 7. Both of those ordered pairs work. And the ones in neither column won't work for those. And the ones in the first column will work for the equation y equals 2x minus 2. Okay, try this set. See if you can figure out where these 8 belong. Okay, if you have done those correctly, there's where you should have classified each of those ordered pairs. Now, we've already also talked about this a little bit, but let's say that I give you a line and I ask you to give me some ordered pairs that are on that line, and I tell you what x values specifically that I want you to look at. So the first one is negative 2, and I want to know what the y coordinate is that goes with that. So if I need to know that, I'm going to find x equals negative 2, and it's right there. And do I have to go up or down to be on that line? Think about this. It's almost like if you're trying to get to base, for example. Like if you're playing tag and you're trying to get to base. Think about the line as being base. If you're at negative 2, to get on base, you got to go down to negative 6. So it's negative 2, negative 6. So if x is negative 2, then y is negative 6. Now if x is positive 2, here's where x equals positive 2. Do I have to go up or down to be on the line? I got to go up. I can only go up and down. I can't go side to side. I have to go up to, positive 6. So 2, 6. If x is 0, here's 0 on the x-axis, and guess what? We're on the line. We don't have to go anywhere, so we're at 0, 0. If x is 1, then y is going to be 3. And if I wanted to, I could go, and I could actually come up, see if I could come up with my function table, or see if I could come up rather with the equation that creates that table. Now notice, since 0, 0 falls on the line, that means that I'm not going to be adding or subtracting anything. This is just a multiplication. So this one becomes actually really pretty easy. You should have come up with 3x. Looking at this next one, if x is negative 2, here's x being negative 2, I have to go down 1, 2, 3, 4, 5. X is going to be negative 5. If x is 4, so let's do our function table as we go. If x is 4, then positive 4 is here, and I have to go up to be on the line. So I get to 4, 1. For my next one, if x is 1, here's x being 1, I have to go down to get on the line. So I'm at 1, negative 2. I had to go down 2. And last but not least, if x is 3, I'm on the line, so 3, 0 is my ordered pair there. Now, something that might help you, even though it wasn't one you were asked for, is what if x is 0? That's always helpful to know. If x is 0, then y is at, I have to go down, and I'm going to be at negative. From 0, I had to go down 1, 2, 3. So I would be at negative 3. So what that tells you is something in your function table has to be minus 3. And if I look at this, This one actually you should see pretty quickly. Oh, now that I know that, then it's just x minus 3. I'm not actually multiplying the x by anything. It's just truly taking the x and subtracting 3 from it. Let's